Okay, today we are going to talk about subtracting integers. Yesterday we were adding them, and now we're just going to talk about what happens when we are subtracting. So by the end of today, we should be able to explain how to subtract integers, how it's related to adding integers. You can explain how to model the subtraction of an integer on a number line. Go back to those number lines again. And then also how we can find the differences of integers by reasoning about absolute value. All right, so coming on over here. When we are subtracting integers, to subtract an integer is like adding its opposite. So you'll hear this a lot. We'll say when we're subtracting an integer, we are adding its opposite. So in numbers, if I were to see, let's say 3 minus 4, subtracting that integer is the same as adding its opposite. So if I still had 3, so instead of subtracting 4, it's the same as adding a negative 4. Those two would give me the same amount. And we can show that on a number line. So if I thought of 3 minus 4, here I am at 3, and I want to subtract 4, means I need to go left 4, and so I'm at negative 1. And on that one that we rewrote it as adding the opposite, again, if I start at 3, and I'm adding a negative, so I have to move to the left, adding 4 negative. And again, we get to negative 1. All right, so let's try a couple examples using this number line. If I start at negative 2, I can rewrite it by adding the opposite. So negative 2, instead of subtracting 4, I can think of it as adding a negative 4. Those are the same problem there. So if I'm at negative 2 and I'm going to add negative 4, I have to go left 4. And I can see I end up at negative 6. And that goes back to our last lesson there. They were the same sign, so I add those together and I keep that same sign negative. Here's another one. So again, I'm going to start with my negative 3. I'm subtracting an integer, so it's the same as adding its opposite. Opposite of negative 7 would just be a 7. And this is also where, maybe you've seen in the past, where you're subtracting a negative is the same as adding. So when you subtract a negative, it actually becomes a positive or an addition. So here we go, negative 3. And I'm adding 7, so I'm going to move to the right. 6 and 7, and I end up at 4. All right, and again, there is one where the signs were different, so I have to find the difference. Difference between those is 4, and I use the sign with the larger absolute value. All right, here's the spot where if you want to pause the video, give those a try, and then we'll go over them together so that you can check to make sure you're on the right track. All right, so using a number line to find the difference, think of that as 1 plus a negative 4. So on our number line, there's my 0. These would be my negatives. So I would start at 1. They're not spaced out exactly perfectly here, but, and since I'm adding -4, I want to move to the left 4. And I can see I end up at -3. All right, and then same thing here. This time I'm going to start at -5. Whoops, I'm going to need to go. So I would be doing -5, and I can think of that as adding a -2. Let me erase this one. So let's make this . And then this will be our 0. All right, so again, if I'm going to start at -5, I'm adding -2, so I have to go 2 to the left. I can see how I'll end up at -7. All right, and then this one, 6, subtraction. So I'm going to change that to addition. It's like adding the opposite. So adding the opposite of -5 would be +5. And again, I see that when those two negative signs are together like that, subtracting a negative is the same as adding. And we know that 6 plus 5 is 11. All right, so a couple more examples, and we can try these now without a number line. I can just try to do 3 and think of this as 3 plus a -12. So here's our different signs. I'm going to find the difference between those values, the absolute values, the difference between 12 and 3, 9, and we have more negative in this problem. Our greater absolute value here is a negative, and my answer would be a negative. If I rewrite B, -8, that's going to turn plus. There's my subtracting a negative is the same as adding 13. Find the difference between the two because they are different signs. So 5, more positive, my answer is positive. And this one we could rewrite as 5 plus 4. Overall, get 9. All right, we have lots to try on your own down at the bottom. So if you want to pause those and give them a try, and then we'll go over those. All right, so let's rewrite, and then we can think of it as 8 minus 3. Well, that's actually a problem we can just do on our own. We know that's 5. If I did happen to rewrite it, I could think of it as the same as 8 plus a -3, and overall that's going to give us 5, like we said. All right, here if I think of this as 9 plus a -17, I need to find the difference, which would be 8. My answer would be negative. I have that larger absolute value there is negative. All right, -3 minus 3. Well, that's the same as -3 plus a -3. Same signs, add and keep. -6. Again, this would be like -4 and a -9. Same signs, add and keep. All right, this problem, right away I see I'm subtracting a negative. I know that's going to become a positive. So overall we have 18 on that one. And then here, again, there's that subtracting a negative. That's going to turn positive. So I have -12 plus 12. There's our additive inverse property again. When we're adding opposites, we know they cancel each other out. We're going to get 0. Okay, we have a couple problems, a little word problem here. Which continent has the greater range of elevations? To find a range, we have to do a subtraction. So we're going to compare North America and Africa. And for the range, we can subtract the high minus the low. All right, so for North America, the problem I'm going to be doing is the highest elevation, 6,198, minus the lowest. Okay, and then again, I see that adding, or that subtracting a negative, is really adding. So the total range in elevation, 6,284. That's for North America. And now for Africa, I would be doing 5,895 minus the negative 155. Again, we get into that subtracting a negative, so I know I would be adding. And that's going to give us 6,050. So which one has the greater range? It looks like North America has the greatest range. All right, the polar vortex, haven't had one of those in a while, causes the temperature to decrease from 3 degrees at 3 p.m. to -2 at 4. And then the temperature continues to change by that same amount until 8 p.m. Find the total change from 3 to 8 p.m. All right, so how can we set this up? Let's think of this on a vertical here. So here's our 0 degrees. So I know the polar vortex caused the temperature to decrease from 3 degrees, it started at 3 p.m., all the way down to -2 degrees at 4 p.m. So we know that the whole temperature here went down 5 degrees. I can represent that with a -5. It's going down 5. So if it continues at that same rate, here I am at 4 p.m. I was at -2. And it's going to continue to do that each hour. That was important. So it's going to keep dropping 5 degrees each hour. So that means then at 5 p.m., if it goes down another 5 degrees, I'll be down at -7. 6 p.m., down another 5 degrees. I would be down to -12. 7 p.m., down another 5 degrees, -17. And then finally at 8 p.m., I'm going to end up at -22 degrees. Well, this tells me what the temperature is now at 8 p.m., but the question was asking, what is our total change? I started the day, or at 3 o'clock, at 3 degrees. And since it's asking for the change, I have to subtract. I ended up at -22. So from 3 all the way down, what's that change? Down to -22? Well, this is an example of where we were subtracting a negative. So that's really like 3 plus 22. So there's a change of 25 degrees. Now it started at 3 and it went down to -22. So that temperature dropped. So it went down 25 degrees, which I can represent with a -25. So the change was -25 degrees. All right, and then our last one. While on vacation, you map several locations using a coordinate plane. So we're going to have to make a coordinate plane here. Each unit represents 1 mile. So a cove is at 3, -7. A little reminder, anything to the right is positive, Anything left will be negative. So -1, -2, -3, -4, -5. Anything up, +1, 2, 3, 4, 5, 6, 7. And then down would be our -1, -2, -3, and so on. So I'm going to plot this cove first. We're at 3, and we have our x and our y-axis. This is a little review here. When we write a ordered pair, it goes in XY order. Alphabetical order, you can remember it, XY. So I'm going to go over to 3 on the x-axis, and then down to -7. 5, 6, 7, so all the way down, and that was over to 3 on the x. All right, so that's where the cove is located. And again, that's 3, -7. Island is at -5, 4, so I have to go over to -5 on the x first, up to 4. About right there. So that's my island. And I'm at -5, 4. And then currently I'm at 3, 4. So this is where I am right now. Or this is where I'm starting. It says, am I closer to the cove or to the island? So let's see if I pick a different color here. Let's think about how far am I from the cove? I didn't line that up too well, but you can think I am going from, on my y-axis here, I'm at 4, and I'm going all the way down to -7. So 4 minus -7, there's that adding. That's really 4 plus 7. That's a change of 11. So I'm 11 units from the cove. And then if I do the same thing with the island, how far am I over from the island? Well, now I'm looking at my x-axis. So from -5 to 3, I would go -5 or 5 spaces and then 3 more. That's 8 units. Or 8 miles, really, because they said 1 unit is a mile. So 8 or 11, I am closer to the cove. No, I'm sorry, closer to the island, because that's only 8 units. The cove was 11. So I'm closer to the island. Justify your answer. Well, the cove is 11 units away. The island was 8. So 8 is closer. All right. That ends it here. You guys can go ahead and do your assignment and practice work with this lesson. We'll see you next time.